titled Supporting Construction Cybersecurity Decision-Making Through a Crowdsourcing Platform. The paper was written by me and my supervisor, Professor Borja García Soto, and we are from New York University, Abu Dhabi. So first, I will start with the problem. Construction is increasingly digitalized and connected. So you might ask, why is this a problem? This is actually something amazing. Yes, it is. And we are now using operational technologies on sites, such as progress monitoring robots, bricklaying robots, autonomous excavators, and so on. But every technology that we integrate on site comes with certain cyber threats as well. So these technologies that are digitalizing and automating construction sites also increases the cyber threat surface. And especially when we consider the robotic devices, they are interacting with humans on site. So every cybersecurity issue becomes a safety issue as well. And another problem is construction companies lack cybersecurity expertise and preparedness. So how do we know that? There was a report in 2025, a ransomware report, an industrial report, and they showed that one of the main reasons of ransomware attacks in construction sector was lack of expertise. We also conducted an academic survey in 2022, and we saw that while most of the people that we surveyed were concerned about cybersecurity in the construction sector, only less than 40% had a cybersecurity plan in their organization. So it shows us there's a high concern but low preparedness. And finally, there was a construction risk report from an insurance company, and they showed that construction is one of the most worried about and the least prepared for risk in the construction sector. So our solution is a crowdsourcing platform for construction cybersecurity. So first of all, what is crowdsourcing? It is gathering ideas or services from large groups of people to fix a certain issue. So one of the good examples is Wikipedia. You know, many people from all around the world contribute to Wikipedia to create a knowledge base. So in our case, this was a web-based platform to collect unstructured cybersecurity knowledge through structured open-ended questions. And we created this in collaboration with a large-scale construction company called ALEC. They are based in the UAE, in Dubai. And this is the overall process flow that I will go through one by one to show you how it works. The first step is the contractor needs to decide on a technology that they would like to assess. So it's either a technology that they are currently using on site or they plan to use in the future. In this case, ALEC decided to assess this equipment. It's called Mule MZ100, and it's a lift assist robot that they use on their construction sites already, as you can see on the image on the right-hand side. This robot has operator control interface, it has load sensors, it has built-in cellular connectivity, so it can connect through a SIM card for monitoring, troubleshooting, software updates. I'm just giving these features to understand what are some potential entry points for attackers. And finally, there's a dedicated service port for firmware updates. The second step was to collect responses from contributors. We did it through open-ended questions. Through these questions, we were trying to understand how would people compromise the data of this system, how would they compromise the operations, how they would improve the system to mitigate the risks, and so on. And we distributed this platform, these questions, to 4 departments in ALEC: IT, design, innovation, and digital construction departments. And while actually there are many people in these departments, we only got 11 responses from 11 employees. It kind of proves my previous point that it's really hard to collect cybersecurity knowledge from construction employees. So it shows the level of cybersecurity in construction as well. And you might also ask, why didn't you ask external cybersecurity experts? Why did you ask only construction employees? There were several motivations. The first one is employees better understand their organizations, their operational needs. This was the first reason. The second one is OT safety issues. Since we are dealing with systems that are interacting with the physical environment, there are some safety concerns as well. And finally, the confidentiality concerns. So since employees already have some legal clauses in their contracts, they cannot really reveal any information that they got. Otherwise, with external engagements, we would need to do NDAs. The third step is to analyze the data that we collected from the contributors. So since we collected the responses through open-ended questions, some of the answers are long, some of the answers are short. So we need to segment them into smaller, semantically coherent pieces so that we can better analyze them. For this purpose, first we created the embeddings of the sentences, and then we used cosine similarity to measure the similarity between consecutive sentences. The second step was topic modeling. What topic modeling does is it gets a corpus, a textual corpus, and then it turns it into topics that are relevant to this corpus. For this purpose, we used BERT topic, which is a novel topic model, and we optimize the hyperparameters to maximize the coherence of the final topics. So this coherence is one of the common measures to assess the quality of the final topic model results. And finally, topic modeling output is just a set of keywords. So to make it more meaningful and more understandable for the management, we labeled them and summarized them using a local large language model. These are the hyperparameters that we tested to understand which combination gives the highest coherence as a result. Finally, we got 2 topics for threats and vulnerabilities, totally based on the input that we got, and 2 topics for mitigations. As you can see, they are quite high-level topics. Their summaries are also not very actionable as well. So to make it more useful for the construction management, we synthesize them into actionable recommendations, again using a local large language model. To make it more deterministic, we set the temperature parameter to 0. And finally, we got these 7 recommendations that the construction management and the IT department can get and start deploying. They were around these 4 areas like physical access management, remote access hardening, secure communication, vendor governance. And then we also wanted to see how these recommendations are aligned with industry standards. So we chose ISA IEC 62443. It's a cybersecurity standard for industrial automation and control systems. And they have 7 foundational requirements for OT cybersecurity. You can see identification, use control, system integrity, and so on. When we mapped the recommendations to these requirements, we saw that the 7th requirement was missing, but the other 6 were matching with the requirements. So it shows alignment with the core OT security objectives. So what are the limitations of this study? It is just one case study with 11 employees who are not even cybersecurity experts. So we know that if we make it with a larger pool of participants, the results can improve. The responses were a bit shorter than we expected, so they were mostly about, yes, you should use MFA. That's it, like one sentence, a few sentences, so not very detailed responses. But this is maybe normal for non-cybersecurity experts. And then we didn't have, at least at that time, we didn't have external validation of the results, that mapping that we created. So the future work, which I've already done actually 2 of them, the validation of the mapping, I actually later conducted validation with experts. And actually some of the experts were the people who developed the standard that I showed you. And then we need to have more scenarios to understand how we can actually utilize such platform to understand the cybersecurity issues in construction. And finally, adding a retrieval augmented generation engine to support what we got, the recommendations, with authoritative cybersecurity standards and guidelines, so we can make them more reliable. And this part I've done as part of my PhD as well. Thank you for listening, and I can get any questions.